Hey, AP Chemsters, this is Mrs. Vanderlei bringing you the second part of the Chapter 11.12 blank wall series. So we left off, and I said I wanted to do this and not rush through it. This is putting it all together. This is what AP folks want you to know. So there are really three, four, five different kinds of solids. And the first type is the atomic, so single atomed. And the ones you know is a network. That is your graphite, your diamonds, and your glass. So if you look here, they're high melting point, very, very hard. I've never tried to melt a diamond, don't know why I would, but it's going to be very difficult to melt that. Metallic, you can have some metals that will melt in your hand like gallium. Mercury is a liquid at room temperature, but everything else will have a higher melting point. So it has a wide range, and that's the point I was trying to make here. And then the group A, 8A, which is your atomic, which is your London dispersion forces only. Argon solid, I've never seen it before, so that would be an extremely low melting point if you want to talk about, let's say, solid atoms of your non-metal variety. And then you have molecular solids, which we've already talked about. We spent most of our time in this unit talking about this right here. Again, they have pretty low melting points, your dry ice and your just regular ice. Then finally your ionic. You have very hard, very, very high melting points, and here's some examples. So over here it says problem 21, use the table above and classify each of the following substances according to the type of solid it forms. So why don't you pause this right now and work on answering this and then see what you get. Okay, so how do we do? Gold is metallic. Hopefully you got that right. That's pretty obvious, I would think. Dry ice is over here, so that would be your molecular solid. Lithium fluoride is ionic. Krypton would be over here, group AA, atomic solid. Quartz is over here. That would be your network covalent. SF2 would be over here, so that's what we are talking about earlier. That would be your molecular solids. It's non-metal, non-metal. This is metallic again. Here is your your fructose, your glucose. That would be over here as a molecular solid. Xenon is over here as your group AA atomic solid, and diamond once again is over here as your network covalent. Okay. Let's try the next one. I think this is the last thing we have. Aha! Look at the melting points for those five things. Would you actually do that for me? Get on your phone. You like using your phone anyway. And will you Google that for me? And let's see what we get. Okay, I hope you've spent a little bit of time looking up this stuff. So, how about this? Silicon dioxide, I just found everything in Celsius. So that became 1710 degrees Celsius. And neon was negative 248 degree, 0.6 if you care, degrees Celsius. So really, that's only like 30 degrees Kelvin, which is super low. Lithium fluoride is 1121 is an ionic. Copper I got 1085. And then dry ice was negative 78.5 degrees Celsius. All these are degrees Celsius. So it says rank and justify based on your types of your solid. So which one is the lowest? Obviously, well, let's scroll down here. It's going to be neon. Hopefully that wasn't any shock there. So I'm going to write neon. And then dry ice. Okay, and then the next three are fairly high, aren't they? So it's copper. And then we have lithium chloride. And then we have silicon dioxide. And that does not surprise me at all. That is pretty much going to be your ranking for all the types of substance. So neon is your atomic solid, your group 8A solid. That's your far right-hand side of the periodic table solid, extremely low. Then you have your molecular solid. So do you see the difference between neon? This is atomic solid. Here, right here is your atomic solid. So I'll write that because it's just one atom, in a sense. This is your molecular solid, this is your metal, this is ionic, and this is network covalent. Okay, the music's coming on. I've said everything I can, but that is the basic ranking that you need to know. So the network covalent by far is the largest. There's only three of those to worry about. Most ionics would be next in line. Remember what we said about metals? They have a wide range, and these two are always going to be your lowest. Okay, that's it. Thanks for listening. Bye-bye.